Crack detection magic, the science of wet magnetic particle testing. Welcome to Ship's Tech Talk. In today's video, we are diving deep into a crucial non-destructive testing method used in the maritime industry. It is wet magnetic particle testing, or WMPT. Have you ever wondered how ship engineers ensure that welded joints in ships are free from invisible cracks? Well, this is where WMPT plays a vital role. This method is widely used in ship maintenance, inspections, and repairs to detect even the tiniest cracks in ferromagnetic materials. Stay with us as we explore how this powerful testing technique works, the science behind it, and its applications in the marine industry. Make sure to like, share, and subscribe to our channel for more insightful content on ship technology. Why WMPT? Ensuring ship safety and structural integrity. WMPT is mainly used to detect surface and slightly subsurface cracks in metals that can be magnetized, such as steel. It is a highly effective and quick method used in shipyards, dry docks, and offshore structures to inspect welded joints, hulls, pipelines, and structural components. Since ships constantly face extreme conditions like high pressure, salinity, and temperature changes, structural integrity is essential. Cracks in welded joints can lead to serious safety hazards, including leaks, loss of strength, and even catastrophic failures. By using WMPT, ship inspectors and engineers can identify and fix these defects before they turn into major problems. Tools of the trade. Equipment needed for WMPT. To perform WMPT, we need several essential pieces of equipment. First, a magnetizing device is required, which can be an electromagnetic yoke, a permanent magnet, or a coil to create a strong magnetic field in the metal being tested. Additionally, a demagnetizer is sometimes used to remove residual magnetism from the tested component after the inspection is completed. Safety gear, including gloves, goggles, and protective clothing, is also necessary to ensure the tester's safety. Magnetic magic, sprays, and chemicals, used in WMPT. The success of WMPT depends on the application of specialized chemicals or sprays. The key ingredient is the wet magnetic particle suspension, which contains fine iron oxide or ferromagnetic particles suspended in a liquid carrier, such as water or oil. These particles are coated with a fluorescent or visible dye to enhance visibility under different lighting conditions. On the other hand, visible contrast particles are black or red and require a white contrast background spray to make defects stand out. A carrier fluid, usually a water-based or oil-based liquid, ensures an even distribution of the magnetic particles over the test surface. These chemicals should have good suspension stability, corrosion resistance, and proper viscosity to flow smoothly over the metal surface. The science behind WMPT, how it works. The working principle of WMPT is based on magnetic flux leakage. When a ferromagnetic material, such as a steel weld, is magnetized, the magnetic field lines pass through the material. However, if there is a crack or discontinuity, the magnetic field gets disturbed, causing leakage at the defect site. When the liquid suspension containing magnetic particles is applied, these particles are attracted to the leakage field, forming a clear indication of the crack. This process allows inspectors to detect even the smallest cracks that might be invisible to the naked eye. Step-by-step guide. Conducting WMPT on welded joints. Now, let's go step-by-step on how WMPT is performed to detect cracks in a welded joint. The first step is surface preparation. The test surface must be thoroughly cleaned to remove dirt, grease, and paint, ensuring proper adhesion of the magnetic particles. The second step is to apply a white background spray to the test area, which enhances the visibility of the black magnetic particles. Next, the magnetizing device is applied to create a magnetic field in the test area. This can be done using an electromagnetic yoke, a coil, or by direct magnetization. Once the field is established, the wet magnetic particle suspension is sprayed or brushed over the surface. The fine magnetic particles immediately gather at any discontinuities, forming visible indications of cracks or defects. After inspection, the part is often demagnetized to prevent residual magnetism, which could interfere with the normal operation of ship machinery. Finally, the surface is cleaned, and the findings are documented for necessary repairs or further analysis. WMPT in action, applications in ships and the marine industry. WMPT is widely used in shipbuilding, maintenance, and repair due to its accuracy and efficiency. It is commonly applied to inspect welded joints in ship hulls, ensuring the vessel's structural integrity. Offshore platforms and subsea pipelines, which operate under extreme pressure, also undergo regular WMPT inspections to prevent failures. In ship engine rooms, critical components like propeller shafts, crankshafts, and pressure vessels are tested to avoid mechanical failures. Additionally, WMPT is essential for inspecting anchor chains, deck fittings, and structural supports to ensure they remain safe under heavy loads. With its ability to detect even the smallest cracks in metal structures, WMPT plays a crucial role in maintaining maritime safety and reliability. Final thoughts: the key to ship safety. So, that's all about wet magnetic particle testing. This non-destructive testing technique is a game changer for the maritime industry, ensuring that ships remain strong and seaworthy. By detecting cracks early, WMPT helps prevent costly repairs and enhances safety at sea. If you found this video informative, don't forget to like, share, and subscribe to Ships Tech Talk for more insightful content on ship technology and engineering. Also, hit the bell icon so you never miss an update. Thanks for watching, and see you in the next video.